This is my first presentation at any like professional event or anything really, so please enjoy this train wreck as I so gracefully ram into you and utter devastation. Anywho, the name of the talk is "If You Can't Remember History, Write It So You Can." That was my best, the cleverest one I could come up with. Also, please let me know if I'm not talking enough into the mic. I don't want to do the Rolski thing and remove the whole arm. Anywho, about me, I'm a sweating fat man standing in front of you. But my name is Brian Gottreau, and I work at the Minnesota Population Center at the University of Minnesota. I'm a system administrator there, and a key thing the Minnesota Population Center does is to disseminate census data after harmonizing it across space and time, something like Doctor Who. And actually in the early 90s, originally we had data and it was FTP'd out. And then sometime in the early to mid 90s, there's actually a Perl CGI application to help people like pick what data they wanted. Then at some point that was changed into Java, and then at some point that was changed into Ruby. And it may change again. Also at the MPC, we have about 100 command line utilities written in Perl that the researchers, who are generally social scientists and perhaps some statisticians, use on a daily basis. And also even some of our social scientists are writing Perl, which is pretty interesting. And supporting these command line utilities, we have some modules. So we actually have some dark CPAN or dark PAN there. Anywho, what is history? History is everything that has led up to now. So forget, it's all the ancestors of a branch or commit that you're looking at. So it's the chain of commits, your current commits, parents, and all their parents, and so on, back to the beginning, or beginnings if you have multiple. And commits can share history. So what is a commit? And a commit basically consists of a tree specified by a SHA-1 checksum or hash, which is basically just a directory of files, which in Git are called blobs. And you also have author info and committer info, which is name, email address, and when the committing and authoring was done. And then the commit message saying what you did or why you did it, hopefully. Or it's just a commit message that says whatever, as I often do. And then any number of parents. Originally, Git, you could only have 16 parents, but in 2008, they eliminated that. So you can have as many as you want, 30 or 40 or 500. And a commit's name is just the SHA-1 hash of basically all those parts. There's like also length info and things. So for a blob, also has a SHA-1 hash, but it is not merely the SHA-1 sum of that file, because there's also just basically a length and then I think a null byte. And if any of these parts change, the SHA-1, the SHA, will also change. So that means even if any parents change, you will change. So if you have your head commit, like 10 years ago you misspelled someone's name and you change that, that will cause your current commit to have a different SHA-1 sum. And so that basically means you can't change commits, but you can change a commit-ish, which the git man page, or if you do man git glossary, it'll give you this. A commit-ish is the commit object, or an object that can be recursively referenced to a commit object. Yeah, that's okay. I thought it used to make sense. Perhaps I'm sweating too profusely. Yeah. So basically, it's a commit object or a tag object that then points to a commit or points to another tag that then eventually gets to a commit. But similar to commit-ish is you have refs, which I'm not sure if they're technically commit-ish or not. But that's also what the git glossary says, which is definitely not super helpful. But basically, refs are human-readable names that point to objects or other references. And so you can change a ref in that the human-readable name will stay the same, like master, your master branch, but the SHA sum it points to will change underneath. And that's basically just, that's what's in master. It's pointing to something. And this changing of what the name points to is basically what happens every time you make a commit, because a new commit object created with all the files pointed to it and your commit message and roughly the current time, and it makes a new commit, and then master is updated to point to that new commit. So on to rewriting of the history. So since commits can't really be changed, only references can, really what rewriting history is making new commits based off old commits, which could be making new trees, which are directories and files, based off old things, either removing files from a tree or changing the content of a blob, and then updating various tags and refs that point to these things. And a lot of the downsides that come from rewriting history stem from the changing of tags and branches, because it makes collaboration difficult, because it's possible for two people to have master that point at completely different things, and so pulling and pushes and merges just train wreck, much like this talk. Bringing it all back. Also, people will be mad at you. Online, there is a flow chart of rewrite about when you should or shouldn't rewrite history and how you should do so. And one of the questions is, if it's public, how many people downstream of you, and is it enough to form a lynch mob? And about a year ago, is that readable to anyone? Okay, these are front people. Somebody did something, I don't know who, but then this happened where Ricardo said he rewound bleed one commit, which basically just changed bleed, just one commit. It didn't actually rewrite any old commits or anything, just step back one from a bad merge. And after this, I seem to remember very contentious discussion and lots of rah, rah, rah. But reading back, it wasn't really that. It was just like, yeah, that was bad, and hope that doesn't happen again. But sometimes there are things in a repo that must not be there, like passwords that is improperly formatted over there on the right, or SSL or SSH keys, which just should never be in a repo ever. If a project has passwords in a private repo, then things are sort of okay-ish because they can be removed before you make it public. But they shouldn't be there in the first place, so that's just bad. As an example, there's a project at work where we have a GitHub Enterprise system, and there's a private repo with a Rails app in it, and there's a database YAML file with database passwords. That's okay-ish because it's all private. The developer had a checkout of the code, as one would do being a developer, but then his laptop was stolen. And so now all those passwords are just out there, sort of in the ether. I doubt anyone who's going to come across a laptop will be able to make use of them, but it's still just worrisome. So even if everything's private, not everything is private still. Also, if you're ever in the case where you have secrets in your repo and it's public, the first thing you should do is just assume everyone's seen everything and replace all your passwords and SSH keys or whatnot, because the damage is done, and if the damage is done, it actually might not be worth it to rewrite the history. Pardon me. In addition to things that must not be there, there are also things that should not be there, like binary files, also unnecessarily to the right, or just very large files, and also miscellaneous junk. For the binary files, Git doesn't really handle revisions between binary files well, unless there are filters and things in place to let that happen. And also, very large files just make cloning and other operations a terrible pain. And then just the other junk is just obnoxious. Like if you had like foo.pl.back for no good reason because it's already in a Git repo, or you had derivatives of source files that you don't need there. And then there's also things that you just don't want there, like dumb changes that got merged in, or terrible commit messages, like that are just whatever. So one tool that comes with Git to rewrite history is git filter branch. And the man page says it rewrites branches. And this is the top section of it. So basically how it works is if you don't specify a revision list, which is the last option there, guild filter branch will basically check out, basically will figure out what all commits from the head all the way back to all the ancestors and check them out one by one, apply any of the filters you have on it, like the tree filter, index filter, subdirectory filter. I'll talk about some of those. And then recreate commits with that new information with all the previous information that hasn't been filtered. And if you don't specify a revision list, it only works from head and back, any of those ancestors. So if you're on master and there's a topic branch and you don't specify a revision of those topic branches, then those will not be rewritten, and then you're in a terrible state where you have half rewritten things, and it's a nightmare, much like this. Yeah, a special revision list you can use is -- all, which basically means every revision everywhere, which is basically all I've ever used because it's simplest. The first example is moving everything out of a subdirectory. At my job, we have been migrating several things from SV into Git, and one of the teams migrated everything, but then everything was underneath a Rails directory, which is just suboptimal because you got a CD to that directory for no good reason. So a developer decided to fix that, and moved everything out of the Rails directory and committed it. Is that one shade there? Is that one shade there? There's supposed to be like a background for that. And that did what he wanted to do, sorta. Except that if you wanted to do git log git log and then specify file to see all revisions, you always have to put -- follow to see it through the move. Also, anything like git bisect will break, or you'll have to work around the fact that everything moved halfway. And so it's not great. Probably. I can't really, I can't comment too much about commit messages because mine are not great. Of course, mine are normally just for personal things, so it doesn't really matter. Anywho, what he could have done is this, which is basically a git filter branch with subdirectory filter, which all it does is for each checkout, it takes everything in that subdirectory and moves it to the base directory, and then removes that direct subdirectory. It should now be empty. And if you feel like it, you can see here that there's a tag name filter, which takes if you don't specify a tag name filter, then all your tag objects will not be rewritten, which for a project of work was once done, and then things were being worked on, and then we realized every release, like release 3.8, release 3.9, all the tags point to the same place somehow. I don't think that was this spot. It was nightmare. Nightmare. And here the filter for the tag names is merely cat, so it doesn't do any sort of filtering at all, which is normally sufficient. However, since he did not do that, or perhaps I should say they, did not do that, one could now do this, which could theoretically work, but it may not work, given I know that there are some weird, in the SVN to Git conversion, there's some weird branches where things are outside of the Rails directory, in which case this, since it doesn't have -f, it might like, so this command is fragile, but it generally will work. And if you wanted to make it non-fragile, instead of just having this git move in there, you could write a small shell script or Perl script that checked everything, made sure exactly what was there and what wasn't there, and then very meticulously move things. Second example, removing passwords. Actually, this is the final example, too. I hope you all wanted to have some free time before the next talk, because that's what you're going to get. So let's say we have a database YAML like that with some passwords in it. One thing we do is use a tree filter like this, which uses a Perl one-liner, which should work okay. As long as the database YAML file doesn't move or there's not more than one database YAML file. Actually, one project has like 40 different database YAML files, and then the deployment process, it symlinks to the current one. So this would not be sufficient. But it basically just removes whatever's after the password colon in the file. And you can see there's a prune empty there, which when you rewrite history, if any commit doesn't change any files, then prune empty would remove it. Because, for example, if you had a commit that was just like, I made the password more secure by changing secret to secret123, that commit, after removing passwords, it's useless, so prune empty would remove that. One problem with this is it's very inefficient in the same way tree filter is always inefficient, because for every commit, it has to check out the entirety of the repo and then do stuff to it and then shove it all back in. And if you have 100 commits in a row where a database YAML is not modified at all, you're just redoing this work over and over and over. Or if you have a repo where all the files when they're checked out is about 1 gigabyte, then that was just going to take forever. So some people somewhere made a thing called the BFG repo cleaner. And I know that's a Doom, I think, reference, or perhaps earlier, I don't know. It's very close to my initials. And it is Java-based. I think it's actually written in Scala, but it runs on the JVM. And what it does is that instead of checking everything out and doing stuff with it, it just goes to all the Git objects directly and mangles them. So essentially, it'll go through all the commits, and if you have certain filters on certain commits, it'll say, I'll rewrite those, and then it'll find the tree object in that commit, and then rewrite that tree object. If you want to remove any file, like that's like testdata.huge, it will modify the tree object, or it'll also modify any of the blobs in that tree, like the database YAML file. It can rewrite those. But one thing it does is that each blob has a checksum. So if it sees a file or blob with that checksum, it handles it once, and that's it. Doesn't do it again. Doesn't do it over and over. Also, there's no checking out of things, so there's no I/O constantly for no good reason. And also, it's able to do this in parallel, because it can look at, if you have 16 processes, 16 different blobs, and I'll be rewriting them at the same time. And I believe it's actually recommended in the Git filter branch man page. At the bottom, they recommend using this because it's faster and better and such. But it doesn't have all the flexibility of Git filter branch. And so one of the options to BFG is replace text. Generally, you can just supply a file with each line of something you want removed, and by default, it's replaced with triple asterisk, removed triple asterisk. Or if you want to be fancy, instead of plain text, you can put regex colon and then put a regular expression there, as I have done, and then double equals, greater than, then the text to replace it with. And running this, it does essentially what the previous Git filter branch tree filter did, but much more quickly. One of the features of BFG repo is that it assumes your current, it has this concept of protected blobs, which you see there with no blob protection. It assumes that your head commit and any of the ones that you specify are accurate and valid, like you fixed it here, it's just all the previous history is total garbage. So that would imply that you've already removed the password from your database YAML, but everything else before it still contains it. But if that's not the case, like here, then you need to provide no blob protection, so rewrite every single bit of your history. Also, when you do this in a non-bare, in a Git repo that's not bare, after it's done, things are left half-staged, so one needs to do a git reset -- hard to put the newer version of the files in there. Because if you ran this and then just did cat database YAML, you'd still have the password there. When you do a git reset, it removes it all the way. One problem with this, though, is that the regex is basically just this and then replace it with this plain text, and that may not be sufficient. And also a question you might have is, why not just keep the database YAML out of the repo? Which one project at work does that, which is generally okay. Except in the last couple of weeks, there was some database connection that changed drivers and pointed to a different place, and that couldn't just be fixed, where it needs to be fixed. The developers had to ask me to go onto a Jenkins server and manually edit a file to point to this certain location. So that's not ideal, because in a database YAML and possibly other files that have passwords, some of the things should be revisioned, like the database names, or specific drivers like MySQL versus Postgres versus SQLite, or connection parameters like pooling connections and timeouts and things. So it is useful to have database YAML or similar file in a repository. Luckily, or unluckily, depending on how you feel, if you're dealing with a Rails project, database.yaml is actually run through ERB, which is embedded Ruby, before it's actually read as YAML. So one could, theoretically, if you put in the necessary infrastructure to have a get password function, your YAML could actually look like this, with get password in the thing, so that no passwords are there, but when you deploy it, there's no extra steps to get the passwords used by the system. And also all the other parameters in the database YAML file will be revisioned properly. And as for the slides, it's over. Hooray. Or not. Maybe. So that was rather short. Would any of you like me to stumble my way through get annex invocation? That guy has two thumbs, and he's just showing them to me. Okay. Pardon? Okay. Well, at the beginning, I decided I should make a presentation. That's a terrible idea. As I said earlier, Git does not really deal well with large files particularly well. I think I used too many words there. You may have heard about, I think it's something Git large files or large file support, something that GitHub has done. It's an open source addition to Git where you are able to apply, put source filters in place and like get big files to be stored elsewhere. The way Git annex does it is that if you have a file, you can say git annex add and then the name of the file, and it'll take that file stored in a special place, but in place of where the file was, it'll make a symbolic link into this special place, which is normally if it's in the base directory, .git/annex/objects, and then a big long SHA-256 sum, and then that sum again. So that way, when you then commit it, you're just committing a symbolic link, but that symbolic link contains all the information necessary to figure out exactly what that file was. And then if you configure a git annex server someplace, you can then say git annex copy to this server, and that file will be copied to your git annex server. So then when someone clones your repo, they get a repo, and they have all these symbolic links that point to nowhere because they don't have git annex set up or the files. But then they can just add a remote, git annex remote, and then do all sorts of fancy git annex stuff, or not, and then able to copy it from the git annex server. One problem is that git annex is sort of more, most of the use cases seem to be for like media file collections. Like if you have a ton of MP3s or PDFs or video files and you want to share them between different places, there's a lot of commands to make that happen where things are moved about. There's an Android client for git annex, and there's commands to tell you where all the copies of the files are, so you will never delete the last copy of a file you have. One problem with this is that does not necessarily fit into a standard Git workflow where you have a project and you have like history on GitHub. That just counterproductive. I don't know how to explain it because, yeah, there's no slide for it because it's over. There's a command in Git-annex called Git-annex sync, which basically syncs that repo with every other known Git-annex repo, which is great for media collection stuff. But if you're working in a regular Git, like source code repository, it's shoving Git-annex branches all over the place. So all this Git-annex info is stored in a Git-annex branch that has nothing to do with your normal repository history. It's just a hierarchy of, like, I think 3-letter subdirectories that then have like actual files there. So it's very messy. Also, the Git-annex sync command will merge and commit any stage changes you have, which, if you're unaware of this, will end up getting all sorts of junk into GitHub, which happened at work, and it was weird. Yeah. Any other questions I can stammer through incoherently, or any comments? No.
What's your job if you learn so much about Git?
Say that again.
What's your role? What's your job?
Sysadmin or sysadmin. I've basically dealt with Git because for some reason I enjoy reading man pages and doing stuff, and, you know, being obsessive and compulsive, and others not so much. Also, I kind of am. I seem to be more bothered by secrets in a repository than other people. So that's one reason. Also, I was asked, like, could you set up a Git-annex repository to store these files? And I'm like, sure. Then I had to figure out how to make it work. So that's. I don't know. Any other questions? Comments? Derisions? Thanks.